focus today is called the magic balloon. And the problem is, why does the balloon inflate with A but deflate with B? Inflate means to get bigger, and deflate means to get smaller. Okay? I have two buckets here, A and B. A is on your left, B is on your right. Okay? Now I have here the magic balloon. A red balloon on a bottle in a bottle that's filled with what? Gas, liquid, or solid? What, Darby? How do you know it's not a liquid or solid? How do you know that, Dee?
Because there's nothing in the bottle.
You can't see it, okay? So that's it's a clear colorless gas. Raise your hand if you can name a clear colorless gas. One, name one. Jackie.
Air.
Air. Name another one, Jeremy.
Carbon dioxide.
Carbon dioxide. Jessica.
Helium.
Helium. Name another one, Jake.
Oxygen.
Oxygen, okay. Almost all gases are clear and colorless. All right, now here's a clue about this one. This gas is actually a mixture of three gases. 70% nitrogen, 29% oxygen, and 1% carbon dioxide. What mixture of gases has that composition? Anybody know? Jeremy?
Air.
Air, right. Air is 70% nitrogen. 70% of the air in this room is nitrogen. It's called an inert or non-reactive gas, so it just acts as a filler. You breathe in mostly nitrogen and you breathe out mostly nitrogen. Okay, now I'm going to put this in here and I want you to raise your hand if you see the balloon inflate. Raise your hand if you didn't see the balloon inflate. Okay, that's in A. Now put it in B. Raise your hand if you see the balloon deflate. Raise your hand if you didn't see it deflate. All right, so the problem is, why does it inflate with A and deflate with B? Now, some of you told me that you had seen this before, but remember, in my program, the important thing is not to know the answer, it's to be able to gather data to support your answer. So, who would like to ask a data question that might help to answer this problem? Why does the balloon inflate with A but deflate with B? Chase?
Are they both water?
Let's start out simple. Does A contain water? Yes. All right, who knows the control question? Somebody the control question. Megan?
Does B contain water?
Does B contain water? Yes. All right, now, therefore, what kind of a variable is water? Controlled or manipulated? What kind is it, Jessica? Controlled or manipulated?
Control.
Controlled variable. All right, so what else do we need to find out? Brandon?
Does B have ice?
Does, well, I'm not going to put it that way. Here's what I'm going to, I think I know what you mean, so I'm going to put it slightly differently. Is B cold? You'd like to know that, wouldn't you?
No, does it have ice in it?
Well, would you like to know whether it's cold? Well, he insists on asking if there's ice in it, so we'll put it. Does B contain ice? Now, the reason I hesitated was, I said B contains water. If it contains ice, could that be water?
Yeah.
Ice is just solid water. Okay, does B contain ice? Yes. All right. Now, we know that B is cold, it contains ice. What else should we find out, Jonathan?
Is there only ice?
It's not only ice, no, it's water with ice in it.
Okay, is A cold and does
Is A cold? No. I'm going to give you another chance, Jonathan.
it contain any ice?
No.
Okay.
What should the question be, Joey?
Is A hot?
Is A hot? Yes. All right, now I can write a tentative conclusion because A is hot, but B is cold. All right, that's reliable. Who remembers something that has to be true in order for a conclusion to be reliable? What's something that has to be true to call a conclusion reliable? Mason? The data can't refute it and they have to support it. Well, those data support this and they don't refute it, so it's reliable. But what difference does it make if one's hot and one's cold? Why should that make a difference, Chase? Does anybody know what difference it makes if A is hot and B is? Why does the balloon inflate with the hot water? Who can explain that? Joey?
Because the hot water has more fumes.
Has more what?
Fumes. Like gas.
Why does the hot water make the balloon inflate, Megan?
The hot water from the bucket and the cold air from the glass, and it makes the air hot and makes it.
Anybody want to explain it in a simpler way? Jeremy, why does the balloon inflate with the hot water?
Because then the air turns hot inside of it and rises.
Jeremy says because the air rises. When, I'm going to put that in form of a question. When you heat air, does it blank blank? Okay, now that has 6 letters. Rise only has 4 letters. What word fits, Darby? Expand. When you heat air, does it expand? Okay. 7. When you cool air, does it? Yes. This time it has 8 letters. What's the opposite of expand that begins with a C? Opposite of expand that begins with a C, Emily?
Compress?
C-O-M-P-R-E. Hey, it fits, but that's not, well, that's close, but that's not the word.
Compact?
Lisa? What do you think, Jeremy?
Collapse.
No. Chase?
Compact.
No. Emily?
I was gonna
Emily
say.
thought she had another word. Okay, Jonathan, you have your hand up or are you just scratching your head?
Scratching my head.
Okay. I'm going to write it one letter at a time. This is what air does when it's cooled. C O
Composes.
N T
Contracts.
Contract.
R
Contract.
A C T.
Contract.
To contract means get smaller. Okay. When you heat air, it expands when. So I'm going to add that. We have more data now, so I can change the conclusion. I can add to the conclusion. Air expands when it is heated, but contracts when it is cool. All right? Now, that's all you have to have on your record sheet today, except for one more sentence I'm going to add a little later on. So you're not going to have to write very much today. Okay, now that you know that there's air in here, and you know that air expands when it's heated, raise your hand if you see it expand, or inflate. See, the air expands, but the balloon inflates. 2 different words. All right. Now remember, this hot water is cooling down as we go along, and the cold water is warming up. So what effect would that have? What effect would it have if this water is cooling down, Darby? No, not deflate. Who knows what effect it has if this water is gradually cooling down? What effect would it have on the balloon shape? Well, what do you see has happened? What do you see has happened already?
It's going
it didn't inflate as much, right? Okay, now, but you saw it inflate a little. Okay, let's see if it still deflates when we put it in here. Can you, raise your hand if you can see it deflate at all. Okay, well, it's still working. Now, I have the green version of the magic balloon. Clear colorless gas. Who can name a clear colorless gas besides air? Name one, Kendall. Huh? Oxygen, but it's not oxygen. Tanner?
Carbon dioxide.
Carbon dioxide. This is carbon dioxide. Okay. Raise your hand if you see it inflate at all, because remember, this water is cooling down now. Raise your hand if you see it. Oh, all of you saw it inflate a little. Let's see how much it inflates. Well, it's not going to inflate very much. Okay, now let's see if it deflates. Raise your hand if you see it deflate.
I see.
Is it deflating a little?
Yeah.
No.
Yeah.
Yeah.
Okay, raise your hand if you saw it deflate at all. All right, most of you saw it deflate some. All right, does carbon dioxide expand when you heat it?
Yes.
Does carbon dioxide contract when you cool it?
Yes.
Okay. Now we've got the purple version of the magic balloon.
I love that color.
Okay. Raise your hand if you see it inflate at all. Oh, well, first of all, we have to discuss what's in here. Who can give me three words that describe what's in here? 3 words that describe what's in here. It can't be a noun.
Oh, and
Chase.
oxygen.
That.
That's
Clever.
3 syllables.
So
That's a noun. Okay. So 3 words. Who can give me 3 words that describe this? Emily?
Clear color gas.
Well, yeah, gas is actually a noun. Clear colorless gas. Okay. It's not carbon dioxide and it's not air. Who knows another clear colorless gas? Another one. Stevie?
Helium.
Helium. This is helium. Let's see if helium expands when you heat it. Raise your hand if you see it inflate at all. Why will it take longer this time? Who can tell me why it'll take longer this time? Why? Why will it take longer this time, Jonathan?
Because the water's cooled down.
Oh, it actually didn't take longer, did it? Look at that.
I
I'm
don't
gonna see how much that will inflate. Because this is, raise your hand if you didn't see it inflate. Got a couple of wise guys in this class. Okay. Raise your hand if you see it deflate.
No.
yeah, it's getting better.
No.
I can see it.
Yeah.
Raise your hand if you didn't see it deflate. Okay. Does helium expand when you heat it?
Yes.
Does helium contract when you cool it?
Yes.
All right. That leads us to the universal law that this is centered around. Now, I'm going to add it to the conclusion. I told you I'd have one more sentence there for you to write. This is the universal law that this focus is centered around. I'm going to put it in parentheses to indicate that it's a universal law. Who can tell me where a universal law is always true? Where is a universal law always true? Well, somebody ought to get a clue from the spelling. Where is the universal law always true, Emily?
In the universe?
Everywhere in the universe. Other planets, other solar systems, other galaxies. Okay, here's the universal law. All gases expand when they are heated, but contract when they are cool. Okay, universal law. It's an important law that affects your life every day practically. All gases expand when they are heated, but contract when they are cool. Okay. Somebody ought to be able to tell me of a very familiar, common example that all of you have either observed in person or on TV or read about. What's a very common phenomenon that most of you have ever observed that demonstrate the fact that air expands when it's heated? What is it, Jeremy?
Hot air balloon.
A hot air balloon. Raise your hand if you've never heard of a hot air balloon. All right. Raise your hand if you've actually seen a hot air balloon. Well, most of you have seen it. All right. I used to walk in the Sammamish Valley when I lived over in Issaquah. And it was a favorite place of hot air balloonists. They would drive their pickup trucks out on the big, they liked it because it had a lot of big open grassy fields. They'd drive their pickup trucks and then they'd unroll their balloon out on the grass like that. And then they would set up a battery operated fan like this and they'd blow air into the opening. Okay, now let's say this air was 60 degrees. That's fairly common around here. Okay, they're blowing that 60-degree air into the mouth of the balloon, and the balloon inflates like that. This air is still 60 degrees. Let's say there's 100 cubic feet, which is about the size of the bathroom, and it weighs 10 pounds. 10 pounds of air occupying 100 cubic feet, 60 degrees temperature. Okay, then they take away the fan, and who knows what they put in its place? Raise your hand if you know what they put in the place of the fan. Emily?
Wasn't it like a basket?
Oh, well, they attach the basket later, yeah. What do they put in place of the fan, though, Janelle?
A fire thingy that.
A propane torch.
Yeah.
A fire thingy.
A fire thingy.
Okay, they get a propane torch and they blow a flame in here. Why do they blow a flame into the mouth of the balloon, Jonathan?
Make hot air.
To make the air hot. Okay, so now the balloon, let's say it gets twice as big. That'll make it easier to make calculations. It gets twice as big. Okay, now that air still weighs 10 pounds. Okay, that air still weighs 10 pounds. But now it occupies 200 cubic feet, about twice the size of the bathroom. And now it's 75 degrees. Okay. Now they've got this tied down. They've got this balloon tied down with ropes because at this point it would tend to rise. Why would it tend to rise at this point? Anybody figure out why it would tend to rise? Why?
Because it had so much air in it.
Because it has so much air. No, that's not.
Well, just kind of like a normal balloon.
Well, Wyatt, tell me this: from the first focus we had last September, what kind of things rise? What kind of things rise?
Eggs and
No, well, you're right. Eggs rise. What kind of things rise?